Motor pump controls. In the electrical world, we have two very common pump applications. They're referred to as pump up and pump down. These are for any type of pumping assembly where a motor is driving a pump to either fill or drain a vessel. Now, in very small applications, like a sump pump in the basement, there's only one float switch. In larger applications, we use two. So these are examples of float switches. It's essentially a buoyant ball at the end of a flexible cord, and as the buoyant ball sort of sits on top of the surface of the liquid, as the liquid gets higher and lower, the orientation of this floating portion changes, and inside there is a ball that moves back and forth, which then actuates a micro switch, which is normally open and normally closed contacts. When we look at pump up control, it's when we are filling a tank. And in order to do that, we have a low and a high level. And what we want is for the motor to ensure or allow the motor to turn the pump so that there is at least a minimum amount of water in there, but we don't want it to overfill the container above the high level. And so to accomplish this, what we use is two separate float switches. They are both normally closed float switches, open on rise of liquid, and the high level is placed in the stop portion of the low voltage protection circuit. The low level switch is placed in the start portion. Let's see how this will work. So here are my two float switches. And initially, when I first set up the system, the tank is bone dry. When we energize the system, both float switches are closed, which means initially the motor starter coil will energize, the holding contact will close, and the tank will start filling. And there's the holding path. As the tank fills, it's going to start actuating those different float switches. So you can see the low level opened, but it doesn't stop the motor because of the holding contact in the holding portion of the circuit. The high level is still closed. As the tank continues to fill with water, eventually the high level will be actuated and open. And when it does that, it's going to stop the motor from pumping water into the vessel. Now, for whatever purpose this liquid is being used for, eventually the level will start going down. But watch what happens. As the level goes down, the motor doesn't immediately start. Instead, it waits until the low level has been reached, and at that point, it will start up again, and that way we avoid what's called cycling, or very quick on and off of a motor assembly. And so there we are again, the motor starts up and the whole cycle completes itself over and over as needed. The other type of pump control we have is called pump down, and that's when we're trying to lower the level inside a tank rather than fill it. This is often done in situations where we have uncontrolled stormwater runoff and we need to remove water from different cisterns that hold it for temporary use. We've got a high level and a low level. This time we want the pump to pump down the water until it reaches the low level, but we don't want it to continue going because a pump that runs dry will tend to get damaged. In this situation, we again have two separate float switches, but this time it's the complete opposite of the previous circuit. The standard arrangement for float switches is to have the low level in the stop portion of the circuit and the high level in the start portion, and for them both to be normally open. In this situation, again, let's see what happens. Right now, we're at the absolute bare minimum low level of water in the cistern, and there's stormwater runoff coming into the big receptacle holding the water. And as that water level rises, it's going to close the first float switch. That float switch does not start the pump. We wait until we get to the high level, and as that water rises, it will eventually close the high level float switch, which will allow for the motor to turn on. And remember, there will be a holding contact in there that will close also. So now the motor is actively pumping the water out of that cistern, and as it starts to go down, that high level float switch will open, but the motor will continue to run, and that's because of the holding contact. It will continue to drop until eventually we get back to the low level, at which point the motor shuts off, and if it stops raining, the motor stays dormant until the next time that a storm rolls through. Pump up and pump down control, two of the most common pumping applications in the electrical controls, motor control applications.